You might often hear the terms of supervised machine learning and unsupervised machine learning. In this lecture, what we're trying to do is we will talk about what is the difference between supervised and unsupervised machine learning and what kind of problems that can fall into these categories. So the supervised machine learning is basically teaching the model or the machine learning model to solve a problem using labeled data. That is, for example, if you're trying to classify a cat from a dog, you simply will have images with cats labeled as cats and images with dogs labeled as dogs. So this is very straightforward supervised machine learning. You're having labeled data, you're teaching the model to give you the output, which is telling to you this is a cat or this is a dog based on the data that you have labeled. So of course, one of these methods is this one, which is binary classification. It's a dog or it's a cat or not cat, or multi-class classification. And this is basically if you have dogs, many species of dogs, and you want to classify which species belongs to which category, then you will have these classes of these species of dogs. Or another type of also supervised learning is regression. That is, you're trying to predict a value. For in our case, what we will do is we will predict the remaining useful life of aircraft engine. So we are predicting a value. So this is a regression problem, and this is also a supervised machine learning problem, because you are giving the number for this condition or for this time series, whatever it is. This is the number of it. This is the evaluation of it. So this is a regression, and it's kind of you labeling the data with a number. So this is why also supervised machine learning. On the other hand, unsupervised machine learning is you have a data, but it's not labeled. Of course, nothing in the world with like all machine learning is kind of we as a human, we will teach the computer what to do. So we are kind of supervising everything, but of course, as a technical term, we call unsupervised machine learning in which we're training the model using an unlabeled data. And unlabeled data, for example, if you have, let's say, lots of companies and you want to classify these companies into some categories, you want to cluster these data. So this is clustering is considered unsupervised machine learning, and clustering is actually the essence of the unsupervised machine learning, because many applications is kind of follow the idea of clustering, having data and breaking these data into clusters, and then try to these cluster having something, or detect what is the commonalities between them. So clustering is kind of the most clear the most clear example of unsupervised machine learning. Another one is anormality detection. And anormality detection, of course, is another. Of course, there is many ways to do anormality detection, but one of the very strong way to do it is to cluster our data, which is the normal data. We train the model on normal data. We cluster them together. So we will have these clusters of normal data. And once we get a new data, we want to see, is this new data belongs to this cluster or not? Well, basically, we calculate this distance from this cluster. We see, does it fit in this cluster or not? If the distance is far, then we can consider this is not a normal data, and this is a normality. This situation is not normal, so we can consider it a normality. Again, it's kind of clustering, but it's a little bit where we have all our data clustered into, let's say, one cluster, and then we measure the distance between our normal data and any new data. If it's outside this cluster, then we have a normality situation. And this is a very useful method for anomaly detection in machines. Another interesting application of unsupervised machine learning is the association mining. And association mining is one of the methods used for recommendation engines. So for example, if you buy from a shopping a website a specific product, he might recommend you another product. And this recommendation happening, of course, there are many methods, but let's say one of the methods, not so strong, but one of the methods is association mining, which is, for example, somebody bought eggs. If somebody bought eggs, other users, or in the training data, they will buy a cabbage and let's say a corn or whatever. So the association is, if you like this thing, well, other people who like this thing usually like that thing, because every item will have features, and these features somehow clusters into with other items. So we can say that if you like that item with that feature, most likely you will buy the other item with that feature.